Hi, I'm Isaac. I'll be giving kind of the first half of the talk, and then I'll switch over to Immanuel for the second half. So talks are supposed to start with a joke, and I was having trouble coming up with a joke. So I took the entire contents of our talk, and I put it in Gen AI and asked it to give me a joke based on the talk. And what it came up with was, why did the Python developer cross the road? To get to the paved road. And only Immanuel and I really get that joke because we know what the talk is about. But you'll all get the joke too by the time the talk is done. So I'm going to start big and narrow down. Basically, I'll start talking about Intuit's leadership in AI and Gen AI, and Intuit's open source contributions, and then getting to kind of the main topic of raising Python code quality. I'm going to talk about how we did that at Intuit by leveling up the engineering skills of AI practitioners, and then I'll switch to Immanuel to talk about the automation and tooling for productivity. So Intuit's mission is powering prosperity around the world. Everything we do is inspired by this mission, and we have, this is kind of a summary of our platform. There's a lot of stuff here. I'm not going to go through all of it in detail, but basically we have a AI-driven expert platform, and we're serving a range of solutions for different types of customers, ranging from consumers to small business to mid-market, and we deliver this through our four main product platforms, which are TurboTax, Credit Karma, QuickBooks, and MailChimp. And these are just some examples of ways that we use AI to solve our customers' problems. Intuit also has a history of self-disruption and reimagination. We're a 40-year-old startup. We reinvented ourselves every few years. So Intuit started in the era of DOS in the 1980s. Some of you might not remember DOS, but in that case, you can just look it up or ask Gen AI. The last 5 years have really been the era of artificial intelligence. So there's been a lot of hype recently, especially with Gen AI, but Intuit was actually pretty early in the AI space, being in this for 5 years and starting that strategy of having an AI-driven expert platform. Intuit's AI org today is around 3,000 or so AI practitioners. That's just an estimate. I don't know the exact number, most of whom use Python. And raising Python quality across a large org, AI org like that is challenging, but the results are higher productivity, faster velocity, and more customer benefit. So now I'm going to move on to talking about our open source contributions. We love the open source community. We believe in open source. We have a lot of projects and teams that maintain and leverage open source across Intuit. And it's an important part of our engineering culture. If you want to learn more, there's a QR code to take you to our open source hub with more details on all the different open source projects that we have. Just to summarize a handful of them, there's Argo, which is many tools for Kubernetes, including continuous deployment, charts, and workflows. There's also Numa, which is operational data analytics for Kubernetes, including Numa Flow, which is stream processing engine, and Numa Logic, which is ML models and tools for real-time data analytics. And coming soon, so this is something that I worked on quite a bit, along with others. Internally, we call this the recommender library, but when we open source this, we don't have a name yet, so that name is TBD. But basically, this is a library for recommender systems and model architectures. And we use it internally for over 8 different AI use cases across multiple domains, including TurboTax and QuickBooks. Just to give you kind of a high-level overview of what the recommender is, we have this kind of a 3-layer architecture where we've got at the top a recommendation approaches, where you get some data and then it returns a recommended item. And then the next layer would be like a score, item score. So for each possible item that could be recommended, you have something that gives you a score, and then you use that. You can take the one with the highest score, you can do some randomization or something. And then at the bottom layer, are estimators. These are kind of the smallest wrapper for a machine learning estimator, like a scikit-learn classifier, regressor, or neural networks, or XGBoost, or whatever you want. And there's also built-in data validation. So keep your eyes open for that. That should be coming out in the next couple months, or at least I'll try to get people moving on it. So now we're going to narrow down on this idea of raising code quality, Python quality across Intuit by talking about leveling up the engineering skills of AI practitioners. So what is an AI practitioner or data science practitioner? There's these different roles at Intuit, and different companies have different, different definitions of these roles. This is just ones that we use, but other companies might have something else. So if you imagine the product flow going from ideation to production, these are the different kinds of roles that would be involved. An analyst is somebody who, and all these people use Python, an analyst would be somebody who analyzes the data and produces reports or insights that can then be used by the business to make decisions. They also have the very important job of doing, interpreting test results. And a data scientist, their main role is to build models. They might build offline models to get insights about the data or feature importance, or they might build online models that go into production and serve, say, like real-time predictions. And then there's a machine learning engineer, or MLE, and their job is to connect the models to the production systems, the different systems that use them. And then at the far end as software engineers, they are responsible for each of those production systems, taking that output from a machine learning model and having that serve a customer experience or something at the end. So where's the trouble with this kind of setup? I call it the bottleneck is the model handoff. So if you imagine, data scientists come from a lot of diverse backgrounds. My background is physics. They might have PhDs, they might not have PhDs, they might have varying levels of training in engineering or computer science. And as a result, so sometimes you might be in a situation where a data scientist could come up with some prototype model where they've got this Jupyter notebook, they've got a bunch of code, but there's no unit tests, there's no encapsulation, there's they've mostly just written code for themselves, and now for the first time they're writing code for other people, and then they hand this off to an MLE, and the MLE has to take this code and translate it into production code, which is has more needs to be up to a higher standard of quality for like maintainability and readability and that sort of thing. And the reason why this can be a bottleneck is because there might be a knowledge barrier. So the data scientist won't necessarily have the knowledge of production concerns like latency, scalability, things like that. And the MLE might not have the knowledge of the data context, like they might see, oh, this metric is off, I don't know exactly if that's important or not, or this little detail in the data transformations is actually important. So our solution is we're going to shift left, meaning we're going to we're going to teach engineering skills to the people who are higher up the funnel from the engineers, and at the same time raise the level of engineering excellence across the board. So all of these roles will all have better engineering skills. So I came up with this thing that I called Software Engineering Excellence for Data Science, or SEEDS. Possibly my greatest contribution is coming up with a cute acronym. So this is a bi-weekly workshop series aimed at leveling up the engineering skills of all the people that I mentioned on the previous slide. And these are just a list of some topics that we've had in the past, so you can see the kinds of stuff that we talk about. It's a very kind of collaborative environment. And one thing we noticed in this started out as let's try to train the data scientists to have good engineering skills, and what we learned is that MLEs don't even agree on what the best practices are. So it became more about defining what are those best practices anyway, and then sharing them more widely. Here's an example sort of output of SEEDS. It's the concept of an AI project design document. So engineers are very familiar with design documents. They use them all the time. Data scientists, not so much. We've been trying to push this new requirement across the AI org at Intuit that every AI project must have an approved design document before any assets go into production. And why would you want a design document? Well, it's a place to communicate with the cross-functional teams. So if someone wants to know, what does this model do? What is the business problem being solved? What are the dependencies, upstream and downstream dependencies? Document all of this in the design document, and then cross-functional teams can coordinate on that. So some success metrics for seeds. We started in November of 2022. Since then, we've had 38 workshops, including 2 external speakers. Once in a while, we do get somebody from outside to come and talk. Over that time, 49 different teams across Intuit have been represented in these workshops, and there's support from AI leadership. And what I mean by that is the head of that 3,000 people organization, he has personally acknowledged the importance that Seeds has and the impact that it has. So you might be wondering, how did we make it work? Well, the workshops are as interactive as possible. We have a lot. It's not just a lecture. We have a lot of discussion. There's usually one person who kind of comes up with the topic and the slides and everything. But there's a lot of discussions, demos, code sharing. It's a collaborative environment. The other thing was that I got 7 people to volunteer as hosts, and that minimizes the workload on me personally. So this was taking like 30% of my time, and now it's much less because I've got people who can help out. And basically what we do is we have a spreadsheet where the hosts sign up for specific dates, and they go out and find the topic and the person to present. And that divides it up pretty well. So I mentioned sometimes we have external speakers. If you're interested in speaking at a Seeds workshop, it's a great networking opportunity. It's a chance to share and learn best practices from somebody at another company. And so reach out, just find me at the conference, or you can email me. There's my email address. And with that, I'll hand it off to Immanuel.
Does this work? Okay. So now we're going to shift a bit from like teaching and sharing and like deciding what the best Python engineering practices for Intuit are to, can we automate any of those best practices with tooling? Intuit primarily uses Python for AI. There are 4 like big groupings of Python applications at Intuit. Numbers on these slide roughly represent the number of code repos in each type. The first are services, think things like REST, GraphQL APIs. A lot of these are like orchestration of AI. Next, we have like Lambdas or serverless applications. A lot of these do some kind of data processing or data transformation. We have what we call the machine learning models, and these are like your individual scikit-learn, XGBoost, TensorFlow models, like as they're deployed. And then finally, any of these top 3 types can use libraries, basically packages of shared and reusable code. So when we can, we build tooling to automate engineering excellence. At Intuit, we call these things the paved road. The idea is when you're on the paved road as a developer, it makes it easier and faster to build things with high quality. So for example, for a service or a library, when you create one with the paved road, in minutes, it starts out like ready to use with as much production grade setup as possible, so you can go straight into your specific business logic or AI logic. We try to make the code repos come with batteries included. So as much as possible, our starter code follows our company standards. We have like the CI/CD pipelines come fully set up. We recognize that in Python, dependency management is a significant problem. Peter Wang gave a great talk this morning about some of the causes and reasons for that. For Intuit and the types of Python problems we usually solve, we've picked poetry as the tool that it's not like the one tool to solve everything, but for us, it's the tool that makes this problem less painful, at least. An additional improvement on top of that is something we call the software bill of materials. It's a meta package that depends on the latest version of all of our standard dependencies for a service. So each service can depend on this meta package to always get a consistent, working, and stable set of dependencies that's already been tested out. When we can, we use tooling to raise the quality bar. So for example, our libraries use semantic versioning by default, and we automate that in our pull request workflow using a tool called Auto that we've open sourced. One of our most common use cases is REST services. So our service starter code includes standard patterns for building those based on the Fast API framework. We have observability, stuff like logging, metrics, tracing, built in by default. And we also recognize that a common issue that comes up with templates is when you have a code template, what happens when you need to change or upgrade or evolve that template over time? So we've developed tooling to address that problem that allows us to create what we call a campaign that would open pull requests to all of, say, our thousands of existing repos to deliver some update. So I want to give like some examples of what we're actually using Python for at Intuit AI. First, I want to highlight our generative AI operating system that helps our engineers quickly and responsibly experiment and build Gen AI solutions. This is something that we have some public blogs and talks about, so please refer to those if you want more details on this. One specific solution that's built on that Gen OS is Intuit Assist for TurboTax. And for example, it delivers personalized explanations of tax calculations for millions of our customers. Another example that we've built with Python is our document understanding platform. Our customers upload millions of financial documents every year. So we've built a platform with Python that reduces data entry work for them and improves the accuracy of the resulting data. I've been told that this audience likes code, so here's some code. This is an example from our paved road for services, slightly condensed, so it all fits on one slide. This is showing the setup of a microservice instance using Fast API. What I want you to take away from this code is that as much as we can, we've abstracted away common details like metrics and logging setup into library functions so that individual service teams don't need to think or know how to set those up. And by putting them into shared libraries, we can easily update the implementations. To recap, Intuit is a leader in AI and open source. We raise Python quality in AI by leveling up the engineering skills of our AI practitioners. That was Seeds, the first part, and by building tooling for automation and productivity. That's the paved roads. And if you want to apply some of these techniques in your work, some of them are available as open source. So thank you for having us, giving us the opportunity for this talk. I also want to say thank you to all of the teams and people at Intuit that made this work possible. Many, many people beyond just Isaac and myself contributed to what we just showed. We're also hiring, so if you're interested, please scan this QR code, or we have a booth downstairs. Please drop by. And now we have some time for questions, I think.
Great talk, thank you. You mentioned that you have this environment that has CI/CD pipelines, and Mypy was mentioned, and some other things like that. If you're willing to share how you arrive at those decisions of those things and how you expect to handle future changes. Like, I feel like the open source environment changes so fast every few months. So if you're willing to share how that process works for you.
Yeah. I don't have time to go down the complete process. I'll also say that this whole framework is only a couple years old. So we've gone through a few of those transitions, not a lot. I would say the decision process, it's basically looking at what problem we're trying to solve, and then doing an analysis of the available tools, either open source or could we build one in-house, and then just typical engineering pro and con analysis. And then when it comes to hey, the ecosystem evolves, then it's thinking about both is there something new that's better, and is it enough better to be worth the change cost, where we have hundreds or thousands of projects already dependent on the current state. If it's going to be a breaking change, is it worth essentially forcing everyone to migrate? And there has been at least one case where I don't want to name names, but there was a package we depended on that was causing too many bugs and breakages, and we did a somewhat painful migration to something else and had to do a lot of communication and change management with the transition.
Hi, my name is Katya. Great talk. I'm a data scientist myself. I love the initiative Seeds. I was wondering if you can share maybe some results of an impact you observed.
Sorry, results of what?
Of the initiative. Did you see any improvement in the skills?
Yeah.
Thank you.
Yes, the question was about results and impact of Seeds. It's a little bit tricky to measure, because how do you measure how knowledge propagates and how that affects people's work? The most consistent metrics are things like participation, which I track every time, see who's showing up and that kind of thing. As far as what people are learning, we can try to track specific things. So I mentioned the AI project design document. We want to make that a new requirement so we can track how many projects are using it, and basically how well that propagates. Aside from just participation metrics and specific things that come out that you want to be able to track, it's really difficult. Yeah. Oh, go ahead.
Yeah, thanks. It seems like you have a lot of repositories, and I was wondering if you could talk about how you manage dependencies between repos, or is it all done through your internal package index?
Sounds like one for you.
Yeah. So we do have an internal package index, and so in terms of dependencies within our repositories, any repository that can be depended on is of the library type, and so it's going to be then published to the package index with semantic versioning, and then anything that depends on it declares it as a dependency through the PyProject TOML file. But in terms of any decision of what version or what package should you depend on, that's the responsibility of the team owning each particular project to decide what it should depend on.